Hello everyone and welcome to the session 37. Today we will discuss the factors affecting the activity of the enzyme. So in the previous classes we were discussing about what are enzymes, how what are the properties of enzymes, and the classes of enzymes we have discussed. So in today's class we will be discussing about the various factors that are going to uh, affect the activity of the enzyme. The activity of the enzyme is affected by the environmental conditions. Changing these changing these alters the rate of the reaction catalyzed by the enzymes. So the most important factors that are affecting the activity of the enzymes are uh, the temperature, pH. They are the temperature, pH, and they are the temperature, pH, uh, substrate concentration, and the concentration of the enzyme. So these are the four important parameters that are going to affect the activity of the enzymes. So now let us look into all these parameters one after the other. The first parameter is temperature. Now let us see how this temperature is going to impact on the affect the activity of the enzyme. Increase in temperature increases the kinetic energy that molecule possesses. In a fluid, this means that there are more random collisions between the molecule per unit time. Since enzyme catalyze reactions uh, by uh, randomly colliding with substrate molecules, increases temperature, increases the rate of reaction. However, increase in temperature also increases the vibrational energy that molecules have specifically. Uh, 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 in this case, enzyme molecules which put strain on the bonds that hold them together. As the temperature increases, there is a breakage of many bonds. This causes the shape, this causes change in the shape, means the active site is less complementary to the shape of the substrate, so it is likely to catalyze. So it is less likely to catalyze the reaction. Eventually, the enzyme will become denatured. So in simple, it is like if the substrate, if the substrate uh, yeah if the substrate is if the temperature is increasing, the the more and more bonds are going to break, and the enzyme is going to become diluted, sorry, the enzyme is going to become denatured, and will no longer be functional and will no longer be functional. As temperature increases, more enzyme molecules, active site shapes will be less complementary to the shape of the substrate, and more enzymes will be denatured. So this will decrease the rate of the reaction. So in summary, I'd like to tell, as the temperature increases, initially the rate of the reaction is going to increase, and the rate of the reaction is going to increase, and after some time, uh, the rate of the reaction reaches to the optimum, and then uh, the rate of the reaction reaches at optimum, and then uh, uh, yeah uh, reaches optimum because of the increased kinetic energy. However, the effect of bond breaking will become greater and greater, and the rate of the reaction will begin to decrease. uh, yeah, this is what is going to happen in an enzyme substrate uh, catalyzed reaction. So this is the most important thing we need to focus on. As the temperature increases, initially if we take a graph, and if I am going to take this as temperature and this is the velocity of the reaction, so initially the rate increases and it reaches optimum, and as the temperature is going to increase on and on, there is the enzyme starts to denature. The enzyme starts to denature, so the rate of the reaction decreases. So the rate of the reaction decreases. So this kind of graph we are going to get when we do it. Rate of reaction or velocity of the reaction versus the temperature. So initially as the temperature increases, say 10, 20, 30, 40, 50, like that, the temperature is going to increase. The rate of the reaction is going to increase as the temperature increases, but after reaching a particular temperature, say around 37 to 40 degrees centigrade, so usually this is called as the optimum temperature for most of the enzymes. After this temperature, as the temperature increases 50, 60, 70, the enzyme starts to denature and the rate of the reaction also decreases. So this is what is going to happen uh, in an uh, in an enzyme substrate. The impact of temperature on the rate of the reaction. The second important parameter is pH. So pH is another important parameter that is going to affect the activity of the enzymes. So different enzymes have different pH. So some enzymes uh, work at optimum, some enzymes work at neutral pH. Most of the enzymes work good at neutral pH, which is around 6.9 to 7. So the optimum pH is the pH value at which the bonds within the enzyme are influenced by H plus and OH minus ions in such a way that the shape of the active site is most complementary to the shape of the substrate. So it in this particular optimum pH we can expect the maximum velocity of the reaction. The rate of the reaction is high. So any change in above pH or below the optimum pH will quickly cause decrease in the rate of the reaction, since more of the enzyme molecules will have active sites whose shapes are not complementary to the shape of the substrate. So in case of pH, some enzymes work nicely in the acidic environment, some enzymes work nicely in the basic environment, and most of the enzymes they work very good at the neutral pH. So when the pH is altered for an enzyme, apart from say if enzyme is having an optimum pH of around optimum activity at pH 6.7, so if this pH is altered to say 5, so then the activity of the enzyme is going to come down. So it will not be like this. Say it will not be like this. So this optimum activity will come down when the pH is going to change. So this is the impact of pH. Either increase or decrease in the pH from the optimum pH is going to decrease. It is going to decrease. At this particular pH it is high. So and this particular pH is called as an optimum pH. It is called as an optimum pH. Now the third parameter is what is going to happen in an enzyme substrate catalyzed reaction when the concentration of the enzyme is going to be increased. So increasing enzyme concentration obviously will increase the rate of the reaction, as more enzymes will be available to bind with the substrate molecule. However, these two will have an effect up to certain concentration where the enzyme concentration no longer uh, is the limiting factor. So this is the rate of the reaction. So this is the rate of the reaction, uh, and this is the substrate concentration, and here we can have the enzyme concentration. So when we keep on increasing the enzyme concentration, the rate of the reaction will increase. till there is available substrate. When there is no more substrate, the enzyme gets saturated. So even in that time we will have a steady state reaction. So the reaction, we don't have new enzyme molecules to bind to new substrate molecules to bind with the enzyme molecule. So this is going to happen when the enzyme concentration is going to increase. Excuse me. Yeah, this is the overall summary. Let me come to, so this is what is happening is here is, so when the temperature is increasing, when the temperature is increasing, when the when the temperature is increasing, the reaction is also increasing. As the temperature increases, the rate of the reaction also increases. And when the temperature is beyond the optimum temperature, so this particular point is the optimum temperature. So even uh, after the enzyme after this reaction has reached the optimum temperature, even after this temperature, still if we are going to increase the temperature of the reaction, so then what will happen, suddenly the enzyme is going to denature, right? So once the enzyme is going to denature, automatically the rate of the reaction decreases. So temperature is going to have a big impact, more heat, more kinetic energy. So but if it is too high, enzyme is going to get denature. So in a very simple way it is being explained. So here optimum temperature is the temperature where the enzyme substrate catalyzed reaction, the activity or the velocity of the reaction is too high. So that is called as the optimum temperature. So at that temperature, more substrate is getting converted into product. So now let me come to the pH. So this is another important parameter. So we have discussed, say, pH, it ranges from 1 to 14, right, on the Sorensen scale. So we have 1 to 7 as neutral, acids, 7 is neutral, and 7 to 14 is bases. So what will happen at lower pH? When acidic pH, what will happen to the activity of the enzyme? So some enzymes, uh, uh, different enzymes have different uh, at different pH, they have optimum activity. But majority of the enzymes, they have optimum activity uh, slightly acidic pH between 6 and 7. They have maximum enzymes have the optimum activity. So optimum activity is the activity, it is the maximum activity. Maximum activity means more amount of the substrate is converted into product. So it will be different enzymes will have different optimum pH. Some may have optimum activity at 5.5, some may have at 6.5, some may have at 7.5. That depends on the type of the enzyme. So when the pH is 1, majority of the enzymes, the rate of the reaction is too slow. As the pH increases, the rate of the reaction also increases, and they will have an optimum temperature. When the pH is too high, majority of the enzymes, the activity comes down. Even this graph is a bell-shaped graph. So at the middle we are going to have optimum activity. So now let me come to the concentration of the substrate. So in concentration of the substrate, so when we take the rate of the reaction versus the substrate concentration, so substrate as the concentration of the substrate increases, the reaction rate also increases. So see here we are having enzyme plus substrate, and what we are going to do, we are going to increase the concentration of the substrate. So but the concentration of the enzyme is fixed, it is fixed. uh, but the concentration of the substrate is going to be kept on increasing. So what is going to happen to this reaction, enzyme substrate catalyzed reaction? So as the concentration of the substrate increases, there is a steep increase in the rate of the reaction. So this is going to happen till what time? Till all the enzyme molecules, till all the enzyme gets bind to the substrate, till all the substrate molecule binds to the enzyme. They bind to the